7.4, we've been talking about percent in this section. And in particular, last time we looked at 4 different ways a percent application could be asked, I suppose. And these were the 3 different ways. One was finding a percent of a number. So what is 15% of 32? The second one was what is finding a percent one number is of another number. Right? This is like what you would want to tell your spouse at some point. You say, but I saved 33%. Right? Y'all want to know how to do that, right? Mm-hmm. The second one, or the third one, C, or 3, was finding a number when a percent of that number is known. And I've got a nice example to show you this one in a little bit here. So we're going to do 3 applications, one of each type. And we're actually going to do these with proportions. So some of you are still working on your test redos, question number 7, the last one on there, where it asks you to do something with a proportion. And so as we do these, the reason I want to do them with proportions is not necessarily because you can't do them other ways, but because they set up so simply, they're so clean and nice and neat with percents to use proportion form. So let me show you what I need, what I have. Example 3. It says, what is the sale price of a softball if the regular price is $6.80 and there's a 25% discount? Okay, so I get it that there's more than this way to do the problem, but I want to show you this way, all right? So this says that there is a 25% discount, but it wants to know how much I pay. I don't pay 25%, right? How much do I pay of the cost of the softball? 75%. So the first thing to be careful of is that you find what you're really intending to find. Here it's asking us how much we pay, right? What is the sale price? And that corresponds to 75% of the cost. Okay, it's really important. It's super easy to get that part not thought about. So if we set up a proportion, one of your proportions is always going to be a number out of 100. And if you know that percent, in this case 75%, you have half the problem already set up. And that's why this method is so very nice, is because half of the side is the percent side, 75 over 100. Or if this question asked us how much do we save on the softball, we'd be doing 25 over 100. Okay? The other side has to do with the value that we're given and the value we want to find. We are told $6.80. We do have to decide, does that go in the numerator or does that go in the denominator? So now remember, this right here is how much our new price is, 75%. And this was the original price on bottom. Okay? So where will our $6.80 go? It'll go on bottom. And the unknown, the new price, is what we're looking for. So just like back in section 6.4, we can cross multiply. I have 100x. What is 6.80 times 75? Somebody said 510. Is that what I heard? Okay, cool. So I have 510. I divide by 100. And what do I get? Yeah, and you even said it right with the dollars. Good. So I need a dollar sign, and then I've got 510. Okay, so look back at our 3 types of problems. They're right above example 3 in your notes. Which of these 3 types is it? 1, 2, or 3? Which one is it? It's number 1. Yeah. This is a problem of type number 1. We're finding the percent of a number. What is 75% of $6.80? Okay, let's try another one. A ski area reports that 80% of its runs are open. There are 60 runs open. How many runs are at the ski area? So again, the proportion setup is super friendly because half of it is something over 100. I don't care whether you put it on the left or the right, by the way. What number goes above our 100 here? Audience participation time. Nope, it's not 20. It's really the 80. It's really the 80. And the reason it is because it says 80% are open and 60 runs are open. Okay, 60 goes across from the 80, you got it. And what we're trying to figure out is how many runs there really are, right? What corresponds to 100% of the runs? So that would be the number on the bottom across, or yeah, I guess you say across from the 100. So if I cross multiply here, I have 80x equals 6,000. So what will x be here? 75. And we're working with context, so 75 what? Runs. You got it. 75 runs. Okay, now look back. What type of problem is this? It's 3. Yeah, it's finding, what did it call it? Finding a number when a percent of that number is known. So this is a problem number 3 type. Number 5. Mort bought his house in 2008 for $159,000. It was recently appraised for $195,000. What is the approximate percent of increase in the value of his house to the nearest percent? Now there's a couple of ways to do the problem. What do you notice? Elizabeth, was that you? What did you notice? Are you sure? Okay. So there's a couple of things to notice. One is that it asks us about the increase in the value of his house, but it doesn't actually tell us in the problem how much the house value increased, right? It told us what the old value was. It told us what the new value was. Do you see that? So we need to be aware of that in one way, shape, or form, that information is not something that we directly have a number corresponding to right now. So there's 2 different ways that we could legitimately set this up, both of them involving percents. We do not know, in this case, what that percent is. That's exactly what we don't know, right? That's what we're looking for. Find the percent that his house went up in value. So that 100 on bottom, one way to do this problem is to say, okay, well, the original is the 100, right? So that would be his cost of his house, which is $159,000. And what's his current value of his house? Yeah, $195,000. And if we cross multiply this, I have 159,000 x equals 19,500,000. And I would divide by the 159,000. Now, if I do this, what do I get? Like, your calculator will need to tell you this for sure. Okay, and that's a percent that I found. And definitely that's the answer to the mathematics that we wrote down. We need to make sure that it's the answer to that question that we actually found or were asked. The question said, what is the approximate percent of increase in the value of his house? Did his house increase by 123%? No. What did it increase by? 22.64 or 23%, right. 22.64% is the answer to the question. The 100% part of that is the original value that it already was. Are you with me? That's what's going on with that 100 that's already there. So you have to be careful if you choose to do this method that at the end you're being very aware of what you've found and the fact that it doesn't quite answer the question that's asked. One way to avoid that is to set the problem up differently so that when you do the x over the 100% down up here, instead of doing the 195,000 on top of the 159,000, that you only do the value that it's increased here. So instead, you do 195,000 minus 159,000. And if you subtract those, what do you get? Nope, you're right the first time. 36,000 is right. Yeah, it is 36,000. The value of the house actually went up $36,000. Right? That's the actual increase in value, not percentage, but in actual dollar amounts of the value of his home. And we could do the same process. The beautiful thing if we do the cross multiplication and so forth from here is that at the end, we actually get x equals 22.64%. So we front load the subtraction so that at the end we have the actual answer we're trying to obtain instead of doing it in reverse. Both give you the right answer as long as you remember somewhere along the way there's a subtraction of the value of the house. All right. A few things about mental math. It says solve the following using mental math. It says 15% of $42. Now I think we've talked about mental math in here. Have we? Or was that another class? No? All right. That's my other class. Here's the deal about mental math. Mental math means that you can do it in your head, hence the word mental, okay? The problem is that I can't see what your head's doing, so you have to write me down something of what you're doing, all right? So whatever you write down, you're saying to me, I did this in my head. So if you write down that inside of your head you did 42 times 0.15, I'm not going to believe you. I'm just not. That's 2-digit by 2-digit multiplication. It's probably not what you really did in your head. Are you with me? Okay. However, if you told me that in your head you did 10% of 42, I could probably go for that. I think you can do that in your head. What's 10% of 42? It's 4.2. And the reason that's nicely done in your head is because it was just a shift of a decimal place, right? I put the 0 on the end. I don't know really why, but we'll probably cut because we're talking about money, I guess. Yeah. That's 10%. And if I have 10%, what could I do to get 5%? Half it. You bet. So 5%, the way I would get 5% is I would take that 4.2 and I would divide it by 2 to get me 2.1. And I think it's probably pretty reasonable to think you could add 4.2 and 2.1 in your head to get 6.3. So in this case, $6.30. So the mental math that you write down is kind of cryptic, but I got to be able to believe that you really did it in your head. That's really the important part of what you're doing, is that what you're writing down is something that's actually done mentally. Okay? What do you think you might do if you wanted to do 20% of 280? What do you want to do? Huh? Don't round. We want to keep it exact, so no rounding. We're not estimating, though. Okay. We could probably do 10% pretty easily. 10% of 280 is what? 28? Okay. And then what? Yeah, and then you could do it again. And then what would you do? Add. And now some of you might have thought, well, I wouldn't have done it with addition. I just would have doubled it, right? 10% would be doubled, and then I'd get my 20%. So this is 56. So a couple different ways of thinking about it. 10% twice. Okay.
I have a question.
Yeah.
So on the part A, we did the 10% and we took the 5% off of our new value?
Well, what I did to get 5% is I just halved what I got for 10%. So it's the 10% value halved. Yeah. It wouldn't need to be written like that. That's not even how I have it written in my notes right now. I just decided to write it that way this time. I don't know. But It's half of the one I had before. What about 5%? What might you do? Yeah, 10% divided by 2. So 10% is what? 320. And then divide by 2. So what's 320 divided by 2? Yeah, it's 1.6. So $1.60. Okay, and then on D, I'm going to shift gears, and let me tell you why. On D, in theory, you could do 10% and double it, and you could do 10% and half it, and you could get those two values and you could add them together. But you're starting to get a lot of really simple steps, but a lot of them, right? It's simple to take 10%. You can divide by 2, you can multiply 2, but to do all of those things in your head at the same time starts to begin to get to too many things. Are you with me? It's a lot. So there's an easier way to do 25%. It's special to 25%. This is not something that works for every number. But 25% very nicely relates to a specific fraction you know. 1/4, right? Yeah? So another way of doing this problem really is that we want 1/4 of 84. And again, this was conducively done, right? It was done very well because 84 divides by 4 very nicely. What would 84 divided by 4 be? Yeah, 21. So if you were asked to do one of these 25%, the whole idea was that it would be something that's done nicely where you could divide by 4. And that's way easier than doing 10% and doubling it, and 10% and halving it, adding the double to the half to get your sum. Way easier. All right. Example number 7. Why is it possible to have an increase of 150% in price, but not a decrease of 150% in price? Say it really loud, Cassidy. Which one would be a negative number?
The decrease.
Okay. If you decreased it 150% in price, it would be a negative number. And it might be nice to justify with a numerical example to say what we're talking about, right? So like let's say you had a $20 item, and if you decreased it 100%, you'd have a $0 item. So if you decreased it 150%, it would be less than 0, right? So if you decrease by 100%, it's 0. So a decrease by 150% is negative. Typically speaking, people don't pay you to buy their stuff. It doesn't work like that. Wouldn't it be fun? But it's okay to have an increase in 150%, right? That same $20 item, if I increased it 100%, that'd be another $20. And if I increased it another 50%, that'd be 50% of 20, which is 10, right? So I'd add another $10 on. You can always add value. You can just only take away so much. All right. I'm not really sure the interest, yeah. So we have just a couple more slides here about interest that we will do next time. This is one of the places where the book changed quite a bit. Yep, some of these pieces are not here anymore. I need to delete them. Okay, so what will happen is we will finish the interest applications for this on Friday. Everything else, you'll know when this starts in your book because it'll start talking about interest. Just push pause when you get to the interest portion of the questions. But go ahead and tackle the ones that are leading up to that. We'll do group work on Friday as well as finishing the last bit of this section on Friday. I think we probably only have about 10 more minutes, okay? So have a lovely day, and I will see you guys all on Friday.
So will homework be due Friday?
No, it can't be. But I would like for you to do the problems so that you could at least ask me if there's anything weird that's showing up, since Friday's our last day before the test to ask that kind of question. Yes, ma'am.
So I just want to accuracy, like I know that we talked about that that's not the only answer to this.
I didn't grade that problem.
Okay.
Oh, 28's here.
Yeah.
Okay, these are running into each other. So when she looked at it, she didn't see it, and I didn't either, actually.
Okay.
So that's what's going on here. Let me fix that, though.
Okay.
Did
I know
not
that it's
see it
not
written
like
over there.
all correct,
Just
but
space it out a little bit
Yeah,
more
yeah.
so that that is not overlooked next time.
okay, yeah.
You bet.
Do you want me to leave it with you?
No, I want you to take it with you, but let me just fix it.
Okay, yeah.
Oh, it's just this blue. Yeah. So what this is it's worth 1 then.
Okay.
Because you have to talk about reducing. We've already talked about what
Okay.
on there, but. So do this for me. Just send me a picture of this top of this.
Okay.
Just email it. And I'll update that online. Okay?
Okay, thank you.
You bet. Yes, ma'am.
So I see. I mean, I understand why that happens. But for these, like, I know it's. I think it's because it's just. I mean, it helps me know that hey, it's. I mean,
The problem is that rounding, when you put zeros, means that you've rounded it to that place.
okay.
This would be saying that it's rounded to the hundredths, to the hundredths, to the hundredths, to the hundredths. And have you had your science class for these yet? You have the same problem in there. Is that the level of accuracy that a value has been reported to tells you something about how the instruments that are used are being measured and things like that. So you don't want to indicate that there's like more accuracy than really exists.
Okay.
So those extra zeros at the end indicate more accuracy than are really there.
Okay.
Yeah, so that's what's going on there. Yep. Yes, ma'am.
Yes, I know. Do I need to staple it together?
No, in fact, I prefer that you don't because I take them apart the first thing to compare them side by side to each other.
Okay.
So that works.
Thank you.
You bet.
So wait, on the redos,
Yep.
we have to put what we did wrong?
You're supposed to be doing like a reflection on each of them, and the reflection says, what did you do wrong first?
Okay.
And why is that now right? Do you need to keep working on that?
I do.
Okay, then just slide it under my door. Look at your syllabus. It gives some more details about how the reflections are supposed to be worded.
Okay.
Okay. Yeah, but you're welcome to just slide it under my door.
Okay. Thank you so much.
So you said that I don't have any dividers.
Okay, but you gotta come to my office to get those.
Yeah. Okay.
Yes.
Okay. Cool.
Come to my office to get those. I'm happy to give them to you. I've got lots of extras.
Okay.
They'll look like, well, they won't look like those ones. I have different ones. But yeah, I have a whole bunch in my office.
Yeah. My like email has been like messing up.
Oh, I'm sorry about that.
I like.
That's really tough too because you need your email in there for college.
Yeah. So I finally got it all fixed last night.
Good.
And then I was looking through my stuff and I was like,
Oh, I missed this one.